Hello, good morning, everyone. Good morning. How are you all? Please, is can everyone listen? Can everyone hear me, please? Good morning, all. Can you all hear me? All right, thank you very much. Good morning, and welcome back to another session for back-end application development. So last week Saturday, we started a practical on back-end development, right? We started back-end development where we started looking at how to create your database as well as how to go about uh, starting your application development, mostly back-end concerns. So before we begin, from last week, we looked at introduction to back-end at the beginning, and in the course of that, we quickly looked at the components that make up the back-end. Is everyone following me? Is everyone following? Is everyone with me? So, part of the components back of back end development, because last class was actually scheduled to be a practical class, so we didn't look at the components in depth. We just look at some overview of them. We just brushed through them, and then we started practical. So if you remember from the last class, we talked about APIs, application programming interfaces, right? As a component of the back-end development. We looked at servers, right? And then we looked at databases also, and then we looked at programming languages also as part of back-end development components. Yes. So today, for this class, which is going to be purely theoretical, and which is basically it's supposed to be theoretical, we are going to look at in depth into servers. For some of us that are really new into the system and don't really understand or know what a server is, so today we are going to look at in depth what servers are, what are servers, what are the uses of servers, why are servers so important. Almost every day we keep hearing maybe the server is down, the server is down, the server is down. What is actually that server? So we are going to start. Is everyone with us? All right, thank you very much. Yes, everyone is with us. We understand. So the outline for this particular session is we are going to look at the definition of servers, a kind of a not really definition of servers. We're looking at an introduction to servers, of course, which comprises of the definition. We are going to look at types of servers. We have various and different types of servers, so we are going to look at them. We have server structures, the structures of servers, and then how servers work. We are going to look at how servers work, and then we also look at some examples of server operating systems. Because there's usually this misconception of what an actual server is. So we are going to clear that out today with the definition. So based on introduction, we want to understand what is a server. If you are being asked what is a server by somebody, or you want to know what is a server, how do you go about explaining what a server is? You should know, so you should be able to explain it. So basically, a server is a computer or system that provides resources data, services, or program to other computers that are known as clients over a network. So by simple definition, that is what a server is. A server is a computer or a system that provides resources, data, services, or program to other computers that are known as a client over a network. So by this definition, by this definition, I'm sure it's a bit clearer now. So basically, what this means is that a server is just a computer, right? There's nothing special about servers. Okay, yeah, we can say there's something special about server in terms of the resources it has. We're talking about computer resources, maybe the storage, the memory, and all that. But any computer can be a server, right? You can choose to develop a system at home. Yeah, and you can make your own server at home. Like you can create a server at home, maybe from your laptop, from your other desktop computers. You can create a server from any computer, as long as you put as long as you put it with the what is being needed for it to serve. You can create. So basically, a server provides resources. What are these resources? These resources can be processing speed, can be memory, can be storage, right? It can be storage, it can be network, right? It can be anything, the resources. So also data, we added it can provide data, it can provide services or other programs to other computers. So a server is just basically a computer that serves others. It serves others. While others that receive the services from that server are usually called clients. In theory, whenever computers share resources with client machine, they are considered servers. There are many types of servers, including web servers, mail servers, and virtual servers. An individual system can provide resources and use them from another system at the same time, right? This means that a device could be both a server and a client at the same time. So what this basically means is that, like I mentioned earlier, any computer can be a server. Any computer can be a server as long as it can serve others. As long as it can serve others with the resources that is being needed, with the resources that is being needed, information or any other thing. Let's move on. So some of the first servers were mainframe computers or or mini computers. Many computers were much smaller than mainframe computers, hence the name. However, as technology progressed, they ended up becoming much larger than desktop computers, which made the term microcomputers somewhat farcical. So, yeah. Initially, such servers were connected to clients known as terminals that did not do any actual computing. These terminals, referred to as dumb terminals, existed simply to accept input via keyboard or card readers and to return the result of any computation to a display screen or printer. For some of us, I don't know whether we've ever come across there used to be like some mini boxes, right? As in, they are very, very portable. They are very, very portable. So they serve as CPUs. I know some business centers do usually have them. You just see like just a box attached behind the monitor, a small box attached behind the monitor. So basically what that is the terminal. You call that dumb terminal. You can just connect keyboard and then mouse to it and then connect it to the CPU and every other resource and every other computer resources. And over a network, it's being connected to a main computer that provide the services. So every other computing resources right, is provided by the server to that computer. However, you can use it to do your personal stuff, to do your internet browsing, to do your other mini word processing activities and so many other things. But aside that, it doesn't really do much computation, and it doesn't consume a lot of resources. When I say resources in terms of power, it doesn't consume. So that I think some years back, I don't see them now, but I know sometimes I used to see them in business centers. They use them a lot. So they are cost effective. They are not expensive. They are not expensive like a normal CPU. You buy a normal computer desktop CPU and all that. So yeah, so they use that a lot. So those are client machines and those are servers. So usually they receive all their processing resources from the server for computation and every other activities. So later, servers were single powerful computers connected over a network to a set of less powerful client computers. This was mentioned. This network architecture is often referred to as client server model, in which both the client computer and the server processes computing power, but certain tasks are delegated to servers. In previous computing model, such as the mainframe terminal model, the mainframe did act as a server even though it wasn't referred by the name. So basically, what this means, is that is what we've just been saying. Like usually a server computer acts in a client server architecture. What is a client server architecture? That basically means that in this architecture of computing, there's a computer which is the server, right? And there's other computer or other computers that serves as the client. So they collect all their resources, all their computer resources and others from the server. So that model is called a client, that computing model is called a client server architecture, right? So as technology evolved, the definition of server has evolved with it. These days, right, a server may be nothing more than a software running on one or more physical computing devices. We are getting there. So a lot of you might be wondering, because during the last class on Saturday, we downloaded one software which we were trying to use. And I mentioned that software is a server. You can use it to serve your application online, to make it run on to make it available on a network, right? So let me repeat that. These days, a server may be nothing more than a software running on one or more physical computing device, such servers are often referred to as virtual servers, right? So presently, all these things we are just talking about, server. That is where another confusion is. So presently, servers can be just a software, right? Servers can be just a software running on a computer. So originally, virtual servers were used to increase the number of server functions in a single hardware server could do. Today, virtual servers are often run by a third party on hardware across the internet in an arrangement called cloud computing. We will gradually, we are gradually moving towards somewhere. So now we are moving into cloud computing, right? So yes, we are going to discuss that too as part of the back-end development technology, cloud computing. Yes. So in addition to everything that we've said, a server may be designed to do a single task, such as a mail server, which accepts and stores email and then provide it to a requesting client. Servers may also perform several tasks, such as file and print server, which both stores files and accept print jobs from client and then send them on to a network attached to printer. So, for example, in business centers, right, and offices, you usually see an architecture whereby you want to print a document. For example, to be specific, business centers. Let me stick with business centers, right? You want to print a document from your computer. You can print the document, but your computer doesn't have a printer attached. There's no printer attached, right? But you can print. When you print and then you go to the counter or the attendee or the attendant to collect your printed document, right? Okay. So that is a printing server. So that architecture is using a printing server. So which means you send the document from your computer over a network, right? Over a network. The network may be wired or wireless, right? You send it over that network and then it will be printed and then you go and collect it. It's the same architecture in offices as well as the business center. So in that architecture, some of you might be wondering, okay, how is that happening? So that is using a printing server. So you see, printing is the resource. So that server is providing the printing resources. So let's move on to that. So there are different types of servers I mentioned earlier. One is the file server. Let's look at file servers. File server stores and distribute files. That is what they do. The file server. So basically, multiple clients or users may share files stored on a server. Centrally storing files offers easier backup or fault-tolerant solution that than accepting to provide security and integrity for files on every device in an organization. File server hardware can be designed to maximize read and write speed to improve performance. Let me give you an example of how this works. For example, sorry, okay, the slide is not clear. Okay, maybe I should increase the size. Naji Siraj. So is this okay? Okay, so can we move on? So basically, file servers usually you find them in organizations. What they normally do is they store and manage and distribute files. For example, now you are in organization, right? So every document you are going to use, you create a document. Is it a memo within an organization and everything? So everything is being stored. Every work you do on your computer is being done. The files are being stored on the server, right? So when you step out of that organization with your laptop, you can no longer access those files again, depending on how they configure it. You can use VPN, right? But usually normally when you step out of the organization, you cannot have access to those files. So they are not you work on the files on your computer system, right? Be it your laptop or any other machine, but they are stored on the server of that organization over a network. If you want to edit them, you are editing the files on the server of the organization. So you don't have a personal copy of the official and sensitive document on your computer, right, in your possession. That is for security purpose. So that is for kind of security purpose, as well as for backup, Yes. So it does usually organizations do that a lot. So to protect sensitive documents. So you create a file on your computer, you do the word processing, everything, you save it, it will be as if it's on your computer. But it's actually not on your computer, it's on the file server. So you cannot access it unless you are within the organization, you're on the same network within the organization, except you are using VPN. All right. So another type of server we have print servers. Okay, like I mentioned, the business center example, whereby you want to print. Likewise, in organizations too, you see a lot of computers, but not all have printer. If you want to print a document, you just send it to the server, and then you go and collect it where the printer is. You go and print it where the computer. So basically, print servers allow for the management and distribution of printing functionality. Rather than attaching a printer to every workstation, a single print server can respond to printing requests from numerous clients. Absolutely. Today, some larger and higher-end printers come with their own built-in print servers, which removes the need for an additional computer-based print server. This internal printer serves also functions by responding to print requests from clients. So next we have application servers. So application servers run application in lieu of client computers running applications locally. Application servers often run resource intensive applications that are shared by a large number of users. Doing so removes the need for each client to have sufficient resources to run the application. It also removes the need to install and maintain software on many machines as opposed to only one. So basically, this means that, for example, uh, let's say within an organization also, or within a group also, you can have some applications that you want to run with, right? So rather than installing such application on every machine, on every single client, on every single computer, okay, you just install it on one computer, which is the server, which will serve as the server, and then others that require the need to use that application will just need to connect to that server, and then they can get access to that application. So that is a application server. Okay. So basically, and then next we have the DNS server. So the DNS server means a domain name system. Like I mentioned earlier, domain name DNS servers are application servers that provide name resolution to client computers by converting names easily understood by humans into machine readable IP addresses. Okay, so domain name servers, right? Basically, what they usually do is, the address, like URL, right? For example, www.facebook.com, www.mybusiness.com, right? All those are URL, right? However, these are not being understandable by the machine, by the internet, by the protocols. They mean nothing. They are not being understood. So we have a DNS, a domain name system server, right, that maps each address, right, each address to an IP address, because IP address is what the network understood, is what the networks understand, is what the computers understand, right? So, for example, I want to visit a website, and then I'll go www dot the name of the website .com, right, or .com.ng or dot whatever, right? So what usually happens in that is there is a DNS server that hosts, that powers all that, the conversion between the address in human readable form, and then maps it to an address, using an IP address to an IP address, and then takes you to that location where you are requesting for that resource. So that is what basically happened. So for that, we have those kind of servers also. The DNS system is a widely distributed database of names and other DNS servers, each of which can be used to request an otherwise known computer name. So when a client needs the address of a system, it sends a request with the name of the desired resources to a DNS server. So that is just basically, for example, now you want to access facebook.com. So when you go to your browser and you type www.facebook.com and you press enter, after pressing enter, what happens is your computer sends that address, www.facebook.com, to a DNS server, right? The DNS server is a widely distributed database. It's a database that is widely distributed. And then the system, the protocol will go through the database to search for where is www.facebook.com. If it got a match, it will now look at, okay, the IP address. It will now get the IP address. Okay, the IP address is this one is dash dash dot 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 dot. No, the IP address how is 192.178 dot, right? Then it will take that address and then follow it. So that is what it will use to navigate to the location of Facebook server for you, and then it will give you back what you want to do. The DNS server responds with the necessary IP address from its table of names. So that is what usually happens on the internet. So next we have the mail servers. So mail servers are very common types of application server. Yes. Mail servers receive email sent to a user and store them until request by a client on behalf of said user. Having an email server allows for a single machine to be properly configured and attached to a network at all times. So basically, another type of server we have is the mail server. For example, we use Gmail, right? We use Gmail, we use Yahoo Mail, and others. So all those email are being powered by a mail server. We use them to send email like the SMTP protocol. We use that to send the emails and all that. So the servers managing all those kind of things. They manage sending and receiving emails as well as storing those emails. All are being managed by a mail server. It is then read, it is then read it is then ready to send and receive messages rather than requiring every single machine to have its own email subsystem continuously running. So, for example, you have a Gmail account, or you have a Yahoo account, or you have any other email provider account. You can access that from any machine, from anywhere, right? So yes, that is how it works. So you are just kind of having access to their server to send email, to receive your email, as well as to store your email, to reference to them any day at any time you really want to have access to the email. So that is purely the function of email server. So we are going to see furthermore, we are going to see, depending on your project and depending on how you intend to, we are going to see how you employ the use of all these things, all these servers. So next we have the web servers, which are of course are common, which are very, very common to us, the web servers. So one of the most abundant type of servers in today's market is a web server. Oh yes, that is the web server. It's one of the most abundant type of server in today's market. A web server is a special kind of application server that hosts program and data requested by users across the internet or an intranet. So basically, what this means is that the web server hosts websites, right? And our web applications, right? So which can be accessible via the web. We just go on www dot the website name and then .com and all that. So the web server handles all that for us. So it makes our website, our application go live online to the web. Web servers respond to requests from browsers running on client computer for web pages or other web-based services. Common web servers include Apache Web Servers, Microsoft Internet Information Service servers, and Nix servers. So the web servers usually they get requests from web browsers. You know, web browsers are the application we use to browse the internet, right? We are calling websites, we call websites from them, and then we receive information from that website through our web browsers. So yes, they provide services on the web. That is web. They like kind of help us host our application. You've heard of web hosting, right? Web hosting, whereby we have an application or a website we want to host online and then make it available to the world, make it available to everything. So you host it on a server, on a web server. So last class we downloaded XAMPP, right? Which I said it's a web server. You see, it's an application we just downloaded from the internet, open source, but it's a server. It's a web server. So what we are trying to build from the last class, you want to host it using the XAMPP server. All right. So next we have then the types of databases. We have the in the type of servers, we have a database server. So the amount of data used by companies, users, and other services is staggering. Much of the data is stored in a database. That is true. Remember, we said database is a component of backend, right? Because most of the application, almost every application, every system has a server, right? behind it that collects data, that stores the data, that provides the data. If you have to deal with data, actually, dynamic data, then you have to have a database. Except, for example, if you are creating a static website, you just want to just display one single information every single time. It should be there, just nothing is changing, nothing is moving, nothing is changing. Then for that static website, you don't need a database, right? Because it's a design. All the information is part of the design. But when there's a need for an actual information data to be changing for interaction, right? You need a database. So databases need to be accessible to multiple clients at any given time and can require extraordinary amount of disk space. Both of these needs lend themselves well to locating such databases on server. So for example, in an organization, right, that deals with data, large amount of data, very, very large amount of data, so there is a need for a database. And because when working with this data, if you have a single data, if you have a database, it helps you manage your data properly, and there will be integrity in your data. So because of that, you use database servers, and these database servers run database application and respond to numerous requests from clients. So because there will be so much request on those data, right, that the organization works in, there's going to be so much requesting for data of so, requesting for data of so, requesting for this data, that data, all that request, right? So there's a need for a server. It's the server that will handle all these requests. The server will handle all these requests from numerous clients that need this data for this, data for that, data for this from some. Common database server applications include Oracle. I'm sure some of us have heard of Oracle, right? And then we have Microsoft SQL Server, we have DB2 and Informix. There are other servers. There are other servers available that handle database that are purely for database serving. So next, we move on to virtual servers, right? So virtual servers are taking the server world by storm. Remember earlier on, we keep saying servers are computer systems, servers and all that. And then earlier on, we also said servers are moving from actual computers, right? Like hardware to software, right? Okay, so unlike traditional servers that are installed on an operating system or machine hardware, virtual servers exist only as defined within specialized software called hypervisor, right? Each hypervisor can read hundred or more thousand or even thousands of virtual servers all at once. The hypervisor presents virtual hardware to the server as if it were real physical hardware. So what does this basically mean? So what it means is that, let's say, with one single physical machine, right, you can create multiple servers with one single virtual machine. That is what it means by virtual server. So you don't really need to always, whenever you really want to upgrade or whenever you really want to create another system, you don't really need to buy another hardware. whenever you really want to scale up, let me use the word scale up your system, you don't really have to buy hardware for the purpose of making it a server. There are some, there's a new technology actually that you can create a server virtually from an already existing hardware system. So the hypervisor presents virtual hardware to the server as if it were a real physical server, which means you can just create a space. For example, like now, okay, I have a hardware server that I'm running, a very, very powerful machine, and somebody else somewhere wants to wants to also host the same service on the server. I can just create a virtual server for him on my server, right? So he'll be running his own business, right? I'll be running my own business on the same hardware machine, but but different servers. So that is what is meant by virtual servers. That is all what is meant by virtual servers. So one hardware or a single hardware, but will serve the purpose of more than one. So next, the virtual server uses the virtual hardware as usual, and the hypervisor passes the actual computation and storage needs onto the real hardware beneath, which is shared among all the other virtual servers. So next on the type of servers, we have the proxy servers. A proxy server acts as an intermediary between a client and a server, often used to isolate either the client or a server for security purposes. Yeah. So a proxy server takes the request from the client. Instead of responding to the client, it passes the request onto another server. So that is basically what a proxy server is. For example, for example, you are dealing in some sensitive kind of business, sensitive nature, and then you are trying to protect your business or whatever it is that you're doing by all means, right? So you can employ the use of a proxy server whereby when a request is being sent by a client, it doesn't go directly. It doesn't go directly to your server. It has to pass through a proxy server, right? The proxy server receives the response from the second server and then reply to the original client as if it were relying on its own, as if it was a kind of responding or replying on its own. In this way, neither the client nor the responding server needs to directly connect to each other. So like the proxy server is like a middleman in a business, right? Like a middleman. For example, somebody wants to buy a house and there's a agent, and there's the owner. So the agent is the middleman, right? So proxy servers usually serve as the agent, right? Like the middleman. So you don't make the request to go directly. You make the request and then it goes to a proxy server. From the proxy server, it goes to the actual server that you are that you are that you are requesting that services. And then the server also responds to the proxy server, and then the proxy server will now bring back to you, the client, the resources that is being required in terms of information, data, anything, whatever it is that you are needing. So it provides you. So that is how it works. Are you with me? Online, are you with me? Hope everyone is on with me. All right. So let's quickly move on to and finish the type of servers. There we have the plenty. We have many type of servers. So next we have monitoring and management servers. Some servers exist to monitor and manage other systems and clients. There are many types of monitoring servers. Several of them listen to the network and receive every client request and server respond, but some do not request or respond to data themselves. So that is how it goes. So in this way, the monitoring server can keep track of all the traffic on the network, as well as the requests and replies of client and servers, without interfering with those operations, right? A monitoring server will respond to requests from monitoring clients, such as those run by network administrators watching the health of the network. So now let's look at server structures. We've been talking about types of servers, right? Server. We've seen them, a whole lot of types of servers. So now let's look at the structures of servers, right? The concept of server is nearly as old as networking itself. Yeah, of course, networking is so old, like so many decades back. So, and if you look at the technology of networking, it's what actually is powering the server client architecture. It's what made the server technology possible, right? So the concept of servers is nearly as old as networking itself. After all, the point of a network is to allow one computer to talk to another computer and distribute either work or resources. That is just basically it, right? Computing has evolved since then, resulting in several types of server structures and hardware. So let's look at the server structures. We have the mainframe and mini computer. So on this, you could say that the original servers, which are the mainframe computers and later mini computers, handled almost all computing tasks except the interaction with the user through a screen and keyboard, which was left to the client system. All right. So next, we have the computer hardware server. So the computer hardware server. The next major wave of servers included computer-based servers, right? Like we keep talking about, server is a normal computer, it's just an ordinary computer, it can be any computer, right? So in many respects, these servers were nothing more than larger, more powerful desktop computers. Simple. That is just it. Nothing more. There's nothing more. So don't get confused, don't get it twisted. Okay, confused. A server is something like Monsterials and all that. So it was one of the questions I got during the last class, the physical class, that somebody said in Hollywood movies, in the American movies and all that, we keep seeing servers as one big structure, right? With glass, and then that has lights inside with wires that are blinking. I said, yes, absolutely, you are very correct. That's our service. But why, what is the difference of that kind of setting, that kind of structure with a normal desktop computer? And I said that, okay, that structure that you're seeing, that big structure you're seeing, comprises of a lot of computers inside of it that are connected using wires, right? To a switch, to a router, to another computer, to other computers and all that, to ports, to different ports. And it contains the computers in a different in a different uh, hardware design than you normally know, because those usually are blade computers. If I say blade computers, they are not like our normal CPU, desktop CPU computers. They are flat, right? Like video. Like a video, right? We used to have a video VCD, a kind of VCD. They are like VCD device, right? So that is how those computers are. So you slot them inside that casing, that structure. You put plenty of them from top to bottom, and then you wire them, to switches, right, and all that. So, and because of that, we went for a little excursion for participants that were physical for the class. We went for an excursion within our location to show them example of that physically. So I showed them that structure, right? The rack, that black structure, the glass, the rack, and then the blade computers that are normally used as servers. They are powerful. They are powerful, by the way. Powerful in terms of memory, in terms of storage, in terms of processing speed. Yeah. So I showed them the blade machines, right? The networking cables like the switches, the port, the faceplates, and all that. How they are connected, the router, and all that. So I will show them all that. So that idea of server is basically the same. All of them are computers. You can put a monitor to view what is going on inside them. You can just connect them to a monitor and then see what is going on and then do a little configuration, one or two things. But it's not a kind of tough rocket science kind of thing. So always put it at the back of your mind. There are computers, a series of computers connected inside that rack. So yeah, that are servers. So such servers were generally okay. So such servers were generally more expensive and held far more memory and disk space than most client computers. Each server was still a self-contained unit with its own motherboard, processor, memory, disk drive, and power supply. Servers like this were often warehoused in air-conditioned rooms called server room, right? And were later bolted into racks for better storage and accessibility. So you see exactly what I was saying. So the idea of server, the idea of servers, right, and server room, that you see all those all those big structures that are tall. That structure is basically a frame. It's a structure. It's a rack, right? It's a structure that is being designed to hold many, many computers. The computer, the CPU, they are just like CPUs, like what they're in the form of VCD, like I said. That I'm sure we don't have VCDs now, but I'm sure you still understand what I'm trying to say, right? So they are normal computers. We can use a normal operating system on them. We can use a normal operating system we use on our normal PCs on them, right? But there are server operating systems. They can employ they run on server operating systems. I'm just trying to tell you, like, they are normal computers, right? They are normal computers, but they are just designed to be a server to run 24/7, right? To run 24/7. That is why they are being like that. They are designed for that. So yes, so because of that, they have a powerful processor, memories, and power supply. So and then usually the server is housed in a server room for businesses. We call it server room because that is where we keep them, right? That is where we keep them. There's nothing more special about server room. It's just where these computers are. We just keep them there because they are to be running every time. So we keep them there to be taking care of them there. So and then because of their machines that keep running every time 24/7, they keep running all the time. So they will generate heat, of course, right? They are going to generate heat. So that is why we keep cooling the room with air conditions. Anywhere you go to a server room, you see air conditions. You see it's being cooled because of they generate heat. Those machines that keep running all the time without stop, they generate heat. And so with the air condition, we cool their temperature down. So that is just basically what it is. So we have the blade servers. So for some of us that were present at the practicals on Saturday, like I said, we went for a little excursion for about, was it 10, 15 minutes? There about, right? To look at what servers is. So there was a machine, a computer, like I mentioned, the computer that looks like that is flat, like a video VCD. So those are blade servers, right? The original computer server hardware was large and stored in racks that could hold hundreds of pounds. Yeah. Over time, however, faster means of connecting hardware resulted in parts of the server being extracted from a single self-contained device. By removing hard drives, eliminating internal cooling, and the ongoing miniaturization of computer parts, servers were eventually reduced to a single thin server known as the plate server. So that is just it. So rather than you just imagine, you want to build a massive computing service, right? And then you want to create a service, and then you have these desktop CPUs. You need plenty resources, so you need plenty massive these desktop CPUs, big CPUs we used to have before. You see them one big box by the side of the monitor. So you can imagine we are trying to build a server with those big boxes, So it will take quite some time. Like it will not be organized, right? It will be one kind. So that was when the idea of these blade servers came in. That single machines. Those are the blade servers. So yeah, rather than using all those big boxes as into a server, so it's now turned into a blade. So that is just it. So while still stored in racks in server rooms, blade servers are smaller and can be replaced more easily. That is it. They can be installed they can be installed and replaced easily. You just like I showed you example for our participants that were present on Saturday. You see in the rack when you open it, you just pull it out, it will just roll over and follow you, right? So you can take it off, you can take it off, you can just easily push it back. So when you want to work on it, you can just roll it out. You can just the particular blade you want to work with, you can just roll it out, it will follow you out, and then it's openable. The hard drives are detachable, they are easily replaced. You can remove them, you can replace them. If same as the memory, you can just from the front, you can just there are clips. If you just release the clips and all that, so you can remove the hard drive, the memory is on top, you can just open it, and then it's easy to maintain and replace. So Next, in the structure, we have combining servers. So even before virtualization, servers were being extracted from the standard model of a single server operating system installed on a hardware machine. Technology such as network attached storage, right, removed the need for a server to have its own storage. Other technologies such as mirroring and clustering enable pieces of hardware to be combined into larger, more powerful servers. Such a server might consist of several blades, several attached storage devices, and external power supply. Each piece could be swapped out of another while the server was still running. So you see, so that big arrangement, that big arrangement, right? Inside of that, inside of that arrangement, we have the blade computers. Don't forget. Sometimes, depending on how it's been designed, and when you have routers in there, right? We have switches inside. That's why we have a lot of cables, right? And then we have the faceplates, right? Where we connect the RJ45 connections and all that from one server to from one machine to another machine to another machine to another port, outside, going outside and all that. So, and then there's also storage devices attached. There's what we call network attached storage, right? We have network devices also that can be installed. Some of them, like on the servers, like you can have several hardware devices, several storage devices, several hard disks, terabytes, in terabytes on one machine. So it's easily replaceable. When one hard drive is full, you can just come remove the clip, take it out, and then put another one instantly as you keep going. So that is the good thing about this. Yes, please, I will post the lecture. Please, I will post the lecture. Thank you. So, please, I'm going to last one treatment one we are listening right now. All right, please, yeah, sure, please. I will post the lecture. I will post the slides, the previous one and this one also. I will make it available to you. I'll make it available to you. All right. So let's move on. So we have okay. I think we looked at virtual. We looked at virtual servers also. Virtual servers still require hardware, but that hardware now runs on a different process known as a hypervisor. In some cases, such as Microsoft's Hyper-V, a full operating system continues to run on the hardware itself. In other cases, so-called bare metal hypervisor can be installed directly onto a server hardware. In both instances, the hardware itself is often spread across an array of blade servers. So what that means, this statement, the hardware itself is often spread across an array of blade servers. That is the word. Array of blade servers. So that is what is inside that black, usually black rack. We call it server rack. That is what we call them. Yeah, so blade of servers, network storage, and power supply, resulting in an environment where it is impossible to tell where any individual server ends and another begins. So let's quickly, we've been talking about server, the types of servers. So let's look at how server works. Let's quickly move on to look at how server works. So for a machine to function as a server, right? A device must be configured to listen to requests from a client on a network connection. So you cannot just decide to say, I want to make this computer. Yes, you can make any computer a server. I said that, right? You can make any computer a server. However, you have to configure it to be a server, to work as a server, right? For example, for example, now you want to develop your own system. Let's say e-commerce system or any kind of system, and then you want to host it, and then you feel like, okay, I want to host this in my house. I want to host this myself. How can you do that? Or let's say you have a personal website. You have a website about yourself, a personal website, and you want to host it, right? Let's say something like your resume. Let's say something like your resume, you want to create a portfolio or profile of yourself online and you want to host it so that everybody will see it. Yes, once you are able to secure a domain name, right, and then you decide to develop that website, you can host it online. You can use your system. You can use your computer and say, okay, I want to host it from my bedroom. Sure, you can do that, but you have to configure that computer to serve as a server. This functionality can exist as part of the operating system as an installed application, role, or a combination of the two. So, for example, when you want to do that, when you want to make a machine to serve as a server, you want to configure it to run as a server, right? Uh, First of all, there's what we call the server operating system. For example, Windows, like we normally use every day, everywhere for our activities, we use the Windows operating system on our PCs, right? So, and aside the normal Windows we use every day, there is Windows also. Microsoft also has a server operating system. So, for example, when there was Windows 98, Windows XP, right? Windows XP, Windows Vista, all of them they have a normal version, and there's a server version. Even Windows, even the present one, we have a normal version, we have a server version. For example, then there is Windows XP Professional, Windows XP Home Edition, Windows XP Office Edition, you know, enterprise, and there's the server. So even now, for every of the present Windows 10, Windows 10, Windows 11, we have the server operating system of it. So that one basically you use it to serve. You use it to when you want to serve, right? So for example, Microsoft Windows Server operating system provides the functionality to listen to and respond to client requests. Additionally, installed roles or services increase which kind of client request the server can respond to. In another example, an Apache web server responds to internet browser requests via an additional application Apache installed on top of another operating system. So, so when a client requests data or functionality from a server, right, it sends a request over the network. Mind you, server client architecture, computer communication, everything we are discussing goes over a network. Without a network, that is not possible. However, mind you, when we say network, right, we don't really mean internet. We don't really mean internet because if you remember, internet is a network of networks. So what I'm trying to say here is that for a remote location, okay, I'm here in Abuja, right? The computer I want to access is in Kaduna, right? Or is in Bayelsa, or even outside Nigeria, or maybe in Togo or Benin or any other remote far place. Yes, I will need internet for that, right? I will really need internet for that. But when it's on a local network, when I mean by a local network, let's say within a building, within a house, maybe within a building, within an office, within the same location, it doesn't really, they don't really, it doesn't really have to be, they don't really have to be internet, but a LAN connection, right? A local area network connection, an intranet, for example, an intranet. So yes, but there must be network, even if it means a one-to-one connection, even if it means a one-to-one connection. The server is here, the client is here. I plug a cable from here to there, whether upstairs or downstairs, But there has to be a network connection. There has to be a connection, whether wired or wireless, also. Yeah. So the server receives this request and then respond with the appropriate information. This is the request and respond model of client server networking. So that is the request for how the client server model is, also known as call and response model. Call and response model. Okay, I have a client. Okay, the client make a request to the server, right, for certain information. Okay, the server said, okay, take this information, right, and then it responds back to the client. So that is how it is. So a server will often perform numerous additional tasks as part of a single request and response, including verifying the identity of a requester, right? Ensuring that the client has permission to access the data or resources requested, and properly formatting or returning the requested response in an expected way. So we mentioned the server operating system, right? So let's look at some examples of some server operating systems. The operating systems you can use as servers. For example, if you want to host your personal website from your house, or you want to host everything that relates to your business, remember, you want to host your business and so on. So which step do you want to follow? How do you go about it? Right? So for example, for the server operating systems, we have Microsoft Windows Server. Microsoft has a line of operating system called server operating system. Like aside the normal everyday operating system that they provide, that we make them use, right? So they provide us with server operating system. Yes, it's there. So let's see. An argument can be made that Windows for Workgroup was Microsoft's first server operating system. In that version, certain computers could be set to share resources and respond to requests from clients, which make them servers by definition. Microsoft first real server operating system was Windows NT. I think NT stands for new technology, right? Yeah, I think new technology. It was an old operating system back then in the early 90s. The early 90s. Its 3.5 and 3.51 version ran on many business networks until Microsoft released its Windows Server line that continue to exist today. Yeah. So the server line is just Microsoft creating an operating system basically for servers that can be used for serving. That is what the most current Windows Server operating system is Server 2016. So this version supports numerous application and databases, as well as a hypervisor that allows virtual servers. So next, on the example of server operating system, we have Linux, Linux/Unix servers. So these are also major players in server operating system. Is the Linux Unix uh, line operating system. So Linux is a Unix-like operating system. Yes. So Linux is an operating system, right? That was let me say created to be kind of a kind of Unix-like operating system from Unix. So it is an operating system that is powerful, right? So the truth is, most of the servers across the world, across the globe, almost everywhere, they run on Linux. They run on Linux. So, like, if I say literally, almost the entire internet because runs on Linux for their servers, for their servers, because it's more secured, right? There are multiple versions and flavors of Linux, which include Red Hat, Red Hat Linux. We have Debian, we have CentOS, we have Ubuntu. Ubuntu is one of the most common GUI Linux operating system. So, and Linux is open source. Open source means you can go online on the internet, you can download it, install it, and start to use it. So you can, because like most of our servers, not even most of our servers basically, and everyone we work with runs on Linux servers, right? Windows are not usually Windows is not usually advisable because in terms of security, Linux is more secured, and in terms of other processing capabilities, like because it's Unix based, so it offers more security. So as an open source operating system, Linux is very popular as a web server. That is another reason why it's free, why it's mostly used as a server. It's free of charge. It's open source, right? It's open source. So nobody will bill you. Nobody will bill you for using Linux. But if you use Microsoft, if you use Windows, if you use Windows Server, of course Microsoft will bill you. Or maybe you've been billed by Microsoft. Do you have the license? Do you have the license to use the operating system? But for Linux, nobody will ask. Nobody will question you. You are free. You can do as you wish. So often with the Apache and web application servers installed. So usually when you have the operating system, when you have the server operating system, then you can also install the application servers. Like, okay, is it the web, is it the is it the web server you want to install? Okay, is it the application server you want to install? You can go ahead and do that. You can go ahead and do that, and then do the necessary configuration, port configuration, and then you'll be good to go. And then you are already serving. You're online and already serving. So that is how it is. So the next operating system we have the NetWare. Although no longer made, NetWare was a major player in the server software space as the client-server era was ramping up. Eventually, NetWare moved its server operating system to a Linux-based kernel and named it Novell Open Enterprise Server. So NetWare or Novell is no longer in vogue. It's not usually in use at the moment. So basically, Linux has taken over the server business. Let me say it that. Let me say it like that. Linux is leading in the server business. So personally, I will advise you when you want to host your own, when you want to have a server, when you want to deploy a server, you should run on Linux. So next we have the cloud servers, right? Cloud servers. So virtual servers hosted on a third-party infrastructure on an open network, such as the internet, are called cloud servers, right? There are numerous cloud service providers these days, including Google's cloud platform, Microsoft Azure, and IBM Cloud. So yes, you see, like during the last class, we mentioned the future of back end as part of the features of or new trend in back end development is serverless architecture. So now, having a server and maintaining a server, it's actually not an easy task. It's not funny. Take for example, a server on the network has to be online 24/7. There should never be a moment, a time when it should be down, right? Just imagine your banking application, your banking system, it's down. How do you feel? What happens when they say, oh, so bank server is down? You cannot open your mobile application to do your transaction. Just for 2, 3 hours, you can imagine what will happen if that is down for like 2 or 3 hours, right? So servers have to be always up all the time. You want to search the internet, any website, it has to be up and running all the time. So a server up and running all the time has consequences. Have what you will do. First of all, of course, the electricity. Yeah, you have to have uninterrupted electricity, right? You have to have uninterrupted network. Your network must be up and running all the time, right? No downtime. Thirdly, it has to be secured, right? So that it will not be stolen, so that one day one thief will not break into your facility, whether your house or your facility, to steal the server, or maybe break something, or maybe or maybe disconnect something, or maybe tamper with anything, sabotage or not sabotage, sabotage or mistake or whatever it is, it has to be protected, right? So, fourthly, is this machine will be running for months uninterrupted. It will generate heat, right? To keep generating it. Doesn't it get tired? You see, it has to get there, it has to get hot. It gets hot. These computers, they get hot. So how do you maintain them? You have to cool them down, right? And adventure, something happens, and then the machine breaks down. If it breaks down, do you have to does it have to be down completely the entire time before you repair it and then you get it back up? No. So if you look at all these things, you see it's not easy. It's not going to be easy. And it's not easy. First of all, you have to provide security for it, right? So that maybe your children at home, or maybe your other colleagues or whatever, sabotage or mistake, somebody will go and tamper with something. You have to provide security for it. not to be stolen. Of course, you have to maintain the environment so that it will be cooling system, right? You have to look for a cooling system for it, and then the uninterrupted power. Of course, you have to have other power alternatives. Was it solar? Is it anything inverter, solar, generator, whatever it is that you think you can afford, right? And then yes, the network. So if you see all these things, they will require resources. They will require resources. So it's not easy to maintain it. It's not easy to maintain a server. So because of this, there are businesses that open. There are businesses that open, such as Microsoft Azure, right? Google Cloud. So they say, okay, we will provide you with serving services. We provide you with these server services. Pay us some money. We provide you with these server services. So we save you the stress of looking for a location to put your server. We save you the stress of uninterrupted power. We save you the stress of cooling system. We save you the stress of network failure. So now what they usually do is the server is remote. Even you don't even know the location where it is. You just buy the service online. You just pay for it, and then they will give you. They say, okay, you can have access to it. You can host your system. You can host your website on our server from here, right? So that is the cloud server. That are the cloud servers. So you save it on the cloud rather than building an infrastructure in-house. Yeah. So however, the main pioneer of corporate and cloud computing was Amazon's AWS platform. It originally started using spare capacity of Amazon's own server and networks by AWS, but AWS now allows customers to create a virtual server nearly instantly and then adjust the amount of resources that the server may use on the fly. So what this basically means that, okay, now for these people that are into this server business, like the AWS, which were the pioneer, like, right, in corporate cloud computing. So they have a platform online, right, where you go and they give you subscribe and they give you access to host your systems, and then from there you start serving. Because now there are a lot of businesses presently, they don't build their server infrastructure because of those consequences, because of the resources it will require. They don't build those. They subscribe to it from these cloud service providers, and that is advisable. And I will tell you, it's relatively cheap. It's relatively cheap. It's convenient, and it's assuring. You don't have anything to worry about. It's assuring because, of course, when you have the infrastructure in-house, maintaining it, of course, you also have to be paying people. You have to be paying people to manage it for you, and all that. So it's enormous. So, but when you pay a certain subscription fee, everything is being taken care of for you. So today, a server can be nothing more than the data of physical hardware that consists of multiple processors, disk drive, memory, and network connections. But even now, a server is still just a system that responds to a request from a client. That is just it. Nothing more than that. So right now, as part of this module, back-end development, so we've looked at this component. We looked at this component of back-end development. I'm aware you are doing database, right, as a whole, as an entire course in this program. So database is one of the components actually of backend, but because you are doing the database course, if we look at that component, it will be like a repetition. It will be more like a repetition for you. So we will look at the other components by next online class. We look at the API, right? Application programming interfaces, and then yeah, we looked at we looked at API, right? At the next class. So we see everything. We also see everything about APIs. So for this particular lecture, I will make the slides available. I will post them online like immediately, as well as the previous class. So during our physical class, the practicals, we will continue from when we start. We will see how this server work. Like we're working with a web server, right? So you see a web server, how it works. We look at how the web server works. Yes. So at this juncture, if there's any question, please, I would really appreciate. I welcome any question at this juncture. So I'm waiting for the questions, please. If you have any question. So the most interesting thing is that, like I mentioned, if the choice is yours, out of your curiosity, out of your savviness, you can decide to create your own server. If let's say you have in your house, in your house you have kids, right? And then okay, you have a wife, you have kids, 3 or 5 kids, and then each they have a laptop, and they are able to buy them a laptop. So you can decide to kind of do something and then try to say, okay, like as the owner of the house, let me just create a server in my bedroom or in my sitting room, and all these computers will be getting their resources from that. That is another way to control what your kids consume over the internet, right? Because the internet is not a safe place for our kids presently. Yes. So you can decide to say, okay, let me create a server, okay, so that I can control what my kids consume from the internet, or what they do with their laptop, kind of. So you can do all that out, you can experiment all that. So it's no big deal. You can create your own server at home, you can create your own server at work, or is it in your business, your shop, your office, your organization. Okay, you're running a business, okay, you can decide to say, okay, let me create a print server for these computers so that they stop wasting my papers in your shop, so that you stop wasting your papers, printing anyhow. So any document that is printed, of course, you should know about it. It should come through your machine. It should come through your table, something like that. So you can just do one or two things. Get this, check online, get the needed resource for configuration, and then you are good to go. Or within your organization, you have an intranet within your organization. You can also employ the use of all that server and all that. Okay, so I would like to attend one of the practical session. Okay, please. The practical session usually holds on Saturdays. On Saturdays, so the practical session hold on Saturdays. There's one 9 to 11, 9 to 12, and there's 1 to 4, 9 to 12 and 1 to 4. Yes. So back end is 9 to 12, and for database I think is 1 to 2, 1 to 4. Yes. So the link. Okay, somebody's asking for attendance link. Okay, the attendance link will be sent. So yes, let me ensure the attendance link is being sent. Okay, so the attendance link will be sent shortly. The attendance link will be sent shortly. Ali, Ahmed Ali. So please, is there any question? Do we have any question? Okay, so I think it will be sent to the group, the chat, right? So okay. So, okay, so the attendance is going to take some time before they send it actually. Yes, but they will send it. They will send it. So I am still here to get any question. So in the absence of any other questions, I think let's call this session. Let's bring this session to an end. So we'll discuss, maybe we continue from where we stopped from the practical class on this. All right. So thank you very much. Thank you all, and thank you. God bless you. Thank you for your time. It's nice having you around. Thank you very much.